Hi, here is 曹旭旭 Anzamation. Our topic is the evolutionary history of cryptography and military starting from the First Sino-Japanese War.
From 1894 to 1895, the late Qing government battled with Japan in the Yellow Sea of China. The North Ocean Navy of Qing government was believed to be one of the strongest military force. However, the result of the war is the North Ocean Navy is completely annihilated and around 20,000 Qing soldiers died.
After this tremendous loss, Qing government was forced to negotiate with Japan. When Li Hongzhang went to Shimonoseki, the bottom line of Qing is ceding the Liaodong Peninsula and compensation about 500,000 taels of silver. However, the final treaty indicates that Qing government ceded both Taiwan and Liaodong area to Japan and further compensated for 230 million taels of silver.
So, what made Qing government so passive in the war and negotiation?
The answer is Japan has decoded Qing's telegraph very early, even before the starting of the war.
So, how did Japanese successfully decode the telegraph? We should talk about the principle of telegraph that is used at the time. Starting from April 1870, the British minister laid telegraph line from Guangzhou to Shanghai, which began the spread of telegraph across the whole country. The telegraph that was firstly used may be mainly divided into two parts. One is the transmission part, composed of various types of radio wave, and the other is the encryption part, composed of cipher machine and a code book. The short wave, medium wave, and long wave radio are used to transmit message. Let's get back to the problem. How can an enemy capture a message and further decode it? Firstly, we should know that the radio wave that was used has no directionality, and its transmission speed is very slow, so it was not transmitted and received point-to-point but face-to-face. As long as you take your own station's band and turn it into a band similar to the other station, you will be able to receive the signals that are standing out from others without disturbing it. Additionally, with a code book, you may decode the cryptography message.
In modern time, the military satellite communication is one of the most common techniques in cryptography. This involves several key components and concepts that work together to ensure effective communication across vast distance and in various operational environments. Satellite orbit, for example, determine the coverage stability of communication, and the different communication links ensure the efficiency.
However, there are still many drawbacks of modern cryptography in military. Firstly, military satellite communication may be easily interfered by other electronic devices or natural phenomena such as storms or thunder. Secondly, the data transmission rates through satellite may be lower compared to the communication system on the Earth, which may hugely affect the transmission efficiency of large volumes of data. Another significant drawback is insecurity. Firstly, the military satellite communication has several digital systems, so it is vulnerable, which may make the communications insecure and unstable. Additionally, satellites can be attacked by physical weapons, such as anti-satellite weapons, which can disrupt communication capabilities.
Then, how to improve these drawbacks and keep those secret messages in military? One of the best solutions is using quantum cryptography.
Quantum cryptography is a method that utilizes the principles of quantum mechanics to protect information. The principles of quantum cryptography may involve quantum superposition, quantum entanglement, non-cloning theorem, measurement disturbance, and quantum key distribution. For the principles of superposition, quantum bits can exist in multiple states at the same time that are different from classical bits, which are either 0 or 1. This property creates a completely different encoding system from classical ones.
For quantum entanglement, it indicates that when two qubits are entangled, the state of one qubit is directly related to the state of the other, regardless of the distance between them. This characteristic determines the correlation between the measurement of two parties and thus enhances security.
The non-cloning theorem, which is the biggest contributor of security, it indicates that it is impossible to make an exact copy of a quantum particle. It ensures that an eavesdropper cannot perfectly copy the transmitted quantum information, and it will make interception detectable. Furthermore, thanks to the measurement disturbance, the act of measuring a quantum state affects the result.
Furthermore, one biggest concern at present may be the future quantum computer may decrypt all modern cryptography easily.
As argued above, most of public key cryptography could be decoded by a sufficiently large and stable quantum computer. Additionally, the quantum cryptography may not be safe because it is based on the same principles that a quantum computer uses. As a result, inventors try to create encryption methods that can withstand attacks from advanced quantum computers, which is called post-quantum encryption, it relies on a mathematical structure instead of quantum theorem.
To conclude, the cryptography in military has experienced great change from last century, and it will definitely be improved in the near future. In pre-modern, telegraph is the main forms of military cryptography. However, it is unstable, insecure, and limited.
Nowadays, satellite communication is the primary technique in military. It is more efficient and secure than before, but it still has many restrictions. In the future, the quantum cryptography may be introduced in military to ensure more powerful and safe communication. However, more concern about the quantum computer may result in the development of post-quantum cryptography. That's all for the project. Thank you for watching.